finding the rule for an inverse. Now, I have to be careful with notation though, okay? We saw that f negative 1, that g negative 1 in the previous slide. That was kind of implying that the inverse of the function is also itself a function. That does not always happen. Especially when we talk about quadratic functions. That does not happen all the time. So we have to be careful about that because not every time I take an inverse of a function do I end up with the function itself. First I want to find the rule for the inverse of the function and include the domain and range. Okay, well, to answer the question about domain and range of the inverse of the function, I better start with the domain and range of the original function. In A, I do have a linear function, which is a polynomial function, but it's also a linear function, as I said. There's nothing there that tells me I can't let x be any number it wants to be. And likewise, since it's a line, essentially, it's going to go up and down forever as well. So the domain and range are all real numbers for both of them. That's going to make it easy when I discuss the domain and range later because, essentially I'm supposed to switch the domain with the range when I do an inverse. Well, they're both the same thing still when I do that. So I can tell you right now that the inverse of this function, once I get the rule, is still going to be the domain and range being all real numbers. First I'm going to let f of x be y. I then then I take an inverse, and that's what that I in the circle stands for. That's my notation. I don't know if any particular other teacher or textbook does it that way. But I'm always a big fan of making sure to communicate my rationale. But now once I get that inverse, technically that's the inverse of the function. I still want to solve it for y, because ultimately I still want to get something of the format, y equals some function of x, even if that function now is an inverse. So I'm going to subtract 7 from, first I move the 2y plus 7 on the left, the x on the right. I just like having my variables that I'm going to solve for and isolate on the left. I subtract 7 from both sides, then I divide by 2. In any one of these expressions you see following the y equals would be acceptable answers. X minus 7 all over 2. I could write them as x over 2 minus 7 over 2, because remember division is also distributive. I can write it as 1 half x minus 7 halves, as I was looking more for a slope-intercept look to it. And even the 1 half x minus 3.5 would be, again, another way of writing it. You notice here I do write it as f negative 1 of x. So this is a linear function. It's clearly a function. So the inverse is a function. I am able to use that notation, so I'm good. And again, as far as the domain and range go, if I switch the domain with the range of the original functions, it's still all real numbers for both. So no real big change there. B is a rational function. Okay, we're going to talk about rational functions in different places throughout this course. We're going to talk about specifically the graphs of them, certain features about them, which we'll talk about extensively. And then towards the end of the course, we're going to see situations where we're going to deal with a lot of limits involving rational functions, and we have to also be aware of certain things about them as well. So, but for this, we're just looking to find the inverse of this rational function. And I also want to be able to discuss the domain and range later. So, first of all, let's take a look at the domain and range for this. Domain, again, is easy. Anything but negative 3, because negative 3 will make the bottom 0. That would be bad. The range, on the other hand, well, we haven't reviewed rational functions yet. There's certain things we can look for that will help us figure out what the range should be. We just haven't discussed them yet. And you might remember them, and that's cool if you do, and that might help you find the range a lot sooner. But I'm going to show you that we can find this range as we go further into the problem quite easily. For the time being, I'm going to kind of ignore the range of the original function and just move on with me finding the rule for the inverse. So again, I'm going to let f of x be y, and I'm going to switch the places of my x's and y's. Which means if I have multiple x's, I'm now going to have multiple y's, and now a singular x. And I still want to solve this for y, which means I want to get y alone on one side of the equation only. That's the important part. Y is alone on one side of the equation only. You want to get y isolated on one side only. If that's not happening, you didn't do your job very well. I want to take steps to get y alone on one side of the equation only. So I multiply both sides, because having a y in the denominator is going to cause its own problems. So I multiply both sides by y plus 3. I distribute the x. So I get xy plus 3x equals y minus 2. Now what I do is I get all my y's on one side and anything that doesn't have a y on the other side. So if you look here, I go from this step here to this one to the next one. I subtracted y from both sides. I also subtracted 3x from both sides. Now the reason why I want to get all my y's on one side and what it works not nicely for me here is I can factor out that y. And when I factor out that y, I go from having two expressions or two terms that have y in it to now a single y term being multiplied by a quantity that has more than one term to it. And now what I can do to isolate the y, since that x minus 1 is being multiplied to the y, I divide both sides by x minus 1. So there's my rule. I could say that f negative 1 of x is negative 3x minus 2 over x minus 1. It's also easy for me when I look at this one, okay, what's the domain of this function? Well, I don't want x to be 1. If x equals 1, that's going to become a 0, so x can't be 1. That's its domain. Well, guess what? That domain is also the original's range, and the original's domain should be this one's range. So, that's how I can find it, because once I'm able to quite easily establish the domain of the inverse, well, the domain of the inverse is the range of the original function. Again, that's the whole idea of what an inverse is doing. And then as far as the range goes for the inverse, well, it's the original's domain. So that's how you can find both of them relatively easy without like going through a bunch of the rules we're going to eventually will talk about when we talk about rational functions.